So today let's solve questions related to sphere. So the first question says that find the equation of sphere which touches this plane at this point and cuts orthogonally the sphere this. So let's see graphically what it says. So there are two spheres. An equation of one sphere is given to us and we are supposed to find the equation of another sphere. It says that these two spheres cut each other orthogonally. That means that if C is radius of sphere which I am supposed to find and C dash is center of another sphere, then the angle that they are forming with each other is 90 degrees. So if small r is my radius of this sphere and let's say r dash is radius of this sphere, then using the orthogonality result I'll get r square plus r dash square equals to c dash square. This result can also be verified using Pythagoras theorem, because this angle is 90 degree and radius of one sphere is r and radius of other sphere is r dash, so c dash will be basically hypotenuse of this triangle, this sphere. Further it says that the sphere which I am supposed to find has a tangent and equation of tangent plane is given to me. Also the tangent plane touches sphere at point P. So let's see what all is given to me. So equation of plane is 3x plus 2y minus z plus 2 equals to 0. Point P is given to me as 1 comma minus 2 comma 1. And sphere, let's say this sphere which I am supposed to find be S1 and the given sphere be S2. So equation of sphere S2 is also given to me, that is x square plus y square plus z square minus 4x plus 6y plus 4 equals to 0. So since P is tangent, since the plane is tangent to the sphere and we know the point where it is touching the sphere, so if I draw a line in between P and C, so the line PC must be perpendicular to the plane. So using this result I can find equation of line PC. So equation of line PC will be x minus 1 upon 3 equals to y plus 2 upon 2 equals to z minus 1 upon minus 1. Here 3, 2, minus 1 are basically direction cosines of normal to the given plane. So I have equation of line PC, so I can easily find any arbitrary point on line PC. So any arbitrary point will be 3t plus 1 comma 2t minus 2 comma minus t plus 1. So this is any arbitrary point on line PC. And since we know that C is basically center of sphere and center of sphere will be of somewhat this form for some value of t. So I got my center of sphere, so C will be of form 3t plus 1 comma 2t minus 2 comma minus t plus 1. This is basically center of sphere. So using this I can calculate radius as well, because P lies on sphere and C is center. So radius will be radius of sphere S1. Radius of S1 will be equals to under root 3t plus 1 minus 1 square, which is basically 9t square, and 2t minus 2 and plus 2 square, which is 4t square, plus minus t plus 1 minus 1, which is basically t square. So this is equals to under root 14t. Under root 14t is my radius of the sphere which I am supposed to find. Also for sphere S2, since we can easily calculate center of sphere S2 and radius, so let's see what is center. So center is basically minus u by 2 minus v by 2 minus w by 2. If my equation of sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals to 0. So if I compare it with the given equation, I'll get my c dash as 2 comma minus 3 comma 0, and radius of this general equation of sphere is r dash equals to u square plus v square plus w square minus the constant term which is d. So using this, if I compare, I'll get my r dash as well. So my r dash will be 4u square plus minus 3 square 9 plus 0 minus the constant term, and my constant term is 4. So I got my r dash as 3. So 3 is radius of given sphere. Now I can use this orthogonality result because I have radius of this sphere S1 as well and r dash as well. Also I know the center of both the spheres. So using orthogonality of sphere result, I'll get r square. Basically r square will be under root 14t, so it will be 14t square plus r dash square will be 9 is equals to c dash minus c whole square. Since I have both c dash and c, so using distance formula I'll get it as 3t plus 1 minus 2. So 3t minus 1 whole square plus 2t minus 2 plus 3, 2t plus 1 whole square, 2t minus 2 and minus of 3, 2t minus 2 plus 3, so 2t plus 1 whole square plus minus t plus 1 whole square. So if I simplify it, I will get 14t square plus 9 equals to 9 plus 4 plus 1 t square plus 1 plus 1 plus 1 plus t into minus 6 plus 4 minus 2. So if I further simplify it, I'll get 14t square plus 9 equals to 9 plus 10, 14t square plus 3 minus 8 minus 4t. So if I solve it, I'll get 4t equals to 6 minus 6. So t equals to minus 3 by 2. So I got my t as minus 3 by 2. So I can easily find out the center and radius of sphere. So my center is 1 minus 3 into 3 by 2 comma minus 2 minus 2 into 3 by 2 comma 1 plus 3 by 2. So if I simplify it, my C is 2 minus 9 minus 7 by 2 comma minus 5 comma 5 by 2, and my radius is 14 r under root 14 into 3 by 2. I am taking positive because radius cannot be negative, so I am just taking mod of t, because anywhere, if here I'll get under root 14 t square, and if I simplify it, it will be under root 14 into 3 by 2. So using this I can easily find equation of my sphere. So equation of sphere will be x plus 7 by 2 square plus y plus 5 square plus z minus 5 by 2 square equals to 14 into 9 by 4. So this is basically my equation of sphere. Let's move on to next question. So the next question is, a variable sphere passes through these points and cut the lines this and this in point P and Q. Also they have given us the distance of line P and Q where A is a positive number. Then show that the center of all such spheres lies on the circle this. Okay. So let us assume a general equation of sphere. Let x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals to 0 be any equation of sphere. Since it is given that it passes through these points, so it passes via 0, 0, plus minus c. So if I substitute these points in the given sphere, let me name it as 1, So I'll get c square plus 2wc plus d equals to 0 and c square minus 2wc plus d equals to 0. So if I solve these equation, I'll get my w equals to 0, and again if I substitute value of w in any of this equation, I'll get c square plus d equals to 0. So from here I got my d as minus c square. So my equation of sphere reduces to x square plus y square plus z square plus 2ux plus 2vy minus c square equals to 0. So now this is my required equation of sphere regarding which a certain information is given to me. Also it says that the variable sphere cuts these lines. So my line L1 is y minus x tan theta equals to 0 equals to z minus c. So I can, and my line L2 is y plus x tan theta equals to 0 equals to z plus c. So I can just simplify these into symmetrical form. So what I'll get is x by 1 equals to y by tan theta equals to z minus c by 0, and for line L2 I'll get x by 1 equals to y by minus tan theta equals to z plus c by 0. So it is given that my line L1 touches the sphere 1 at point P and line L2 touch it at point Q. So since my equations are in symmetrical form, so I can easily find out any arbitrary point on line L1 and L2. So let it be equals to T1 and this one be equals to T2. So I can get a variable point P. So my point will be T1 comma T1 tan theta comma C, and likewise my point Q will be T2 comma minus T2 tan theta comma minus C. So since these line touches the given sphere, so P and Q must satisfy equation of sphere. So substituting coordinates of P and Q in equation 2, we'll get T1 square plus T1 square tan square theta plus C square plus 2u T1 plus 2v T1 tan theta minus c square equals to 0. So if I simplify it, I'll get T1 square 1 plus tan square theta will be sec square theta plus 2T1 u plus v tan theta equals to 0. So from here I can find value of T1. So T1 can be either equals to 0 or T1 can be minus 2 u plus v tan theta upon sec square theta. But if you observe that if I put my T1 equals to 0, then I'll get basically these 2 points only which are already given to me, and then I will not lead anywhere. So my T1 cannot be equals to 0, so I can discard this option and my T1 will be this. So if my T1 is this, so I can get a value of point P. So my point P is minus 2 u plus v tan theta upon sec square theta comma minus 2 u plus v tan theta upon sec square theta tan theta comma c. Likewise I can substitute coordinates of point Q in equation 2 and we'll see what we get. So we'll get T2 square plus T2 square tan square theta plus c square plus 2u T2 minus 2v T2 tan theta minus c square equals to 0. So if I solve it for T2, so I'll get my T2 as minus 2 u minus v tan theta upon sec square theta. So using this I can find coordinates of point Q. So my point Q will be minus 2 u minus v tan theta upon sec square theta comma 2 u minus v tan theta into tan theta upon sec square theta comma minus c. Further in question they have given us as that distance PQ is 2a. So they have given us that PQ is equals to 2a. Since we have calculated coordinates of both point P and Q, so we can find distance PQ using a distance formula. So we'll get 2a equals to, let's just do square here itself. So from here I'll get 4a square equals to PQ square. So my 4a square will be, if I subtract P minus Q, so I'll get minus 2u minus 2v plus 2u. I'll get minus 2v tan theta upon sec square theta whole square plus minus 2u minus 2v tan theta. So here I'll get minus 4, minus 2, I guess I'll get minus 4 here. Yeah, minus 4 is here. Here I'll get minus 2u minus 4u tan theta upon sec square theta whole square plus c minus minus c. So it will be 2c, which is 4c square. So if I simplify it, I'll get, let's just take this c this side. So it is 4a square minus c square equals to, if we open the whole square, we'll get 16 v square tan square theta plus 16 u square tan square theta upon sec theta raised 4. So we can further simplify it. 4 balances out it on both sides. So we are left with a square minus c square equals to 4 u square plus v square tan square theta upon sec square theta into 1 upon sec square theta. So if I further simplify it, I'll get a square minus c square equals to u square plus v square tan square theta upon sec square theta will be 1 upon, it will be sine square theta. Sine square theta, and 1 by sec square theta is cos square theta, and 4 is also there. So I can write it as a square minus c square equals to u square plus v square into sine 2 theta whole square. So I can take this sine square theta on the other side of the equation. So I'll get a square minus c square is equals to cosec 2 theta whole square equals to u square plus v square. Okay, so what we are supposed to prove? Okay, we are supposed to prove x square plus y square. So if you observe equation number 2, which we have calculated, so my equation 2 is x square plus y square plus z square plus 2ux plus 2vy minus c square is 0. So from here I can calculate basically center of the sphere. So my center will be minus u comma minus v comma 0. So this is basically the required locus of sphere, because my center is minus u comma minus v. So I can, if let x comma y comma z be my center of sphere, be my locus. So my required locus is z equals to 0 comma x square plus y square equals to a square minus c square cosec 2 theta whole square. This is what I am supposed to prove in this question. So let's move on to next question. So the next question says that find the equation of sphere through the circle this and this in following two cases. So the equation of circle is x square plus y square plus z square minus 4x minus 6y plus 2z minus 16 equals to 0, and 3x plus y plus 3z minus 4 equals to 0. So this basically represents the circle equation, So any equation of any sphere will be x square plus y square plus z square minus 4x minus 6y plus 2z minus 16 plus lambda into 3x plus y plus 3z minus 4 equals to 0. So if I further simplify it, I'll get x square plus y square plus z square plus 3 lambda minus 4x plus lambda minus 6y plus 3 lambda plus 2z minus 16 minus 4 lambda equals to 0. So this is my basically the equation of sphere. So we are supposed to find equation of sphere when this point lies on the sphere. So my first part is when p is equals to 1, 0, minus 3 lies on sphere. So if this point lies on the given sphere, so it must satisfy the equation of sphere. So we'll just substitute the point p in equation of sphere. We'll get 1 plus 0 plus 9 plus 3 lambda minus 4 by 0 plus 3 lambda plus 2 into minus 3 minus 16 minus 4 lambda equals to 0. So if I further simplify it, I'll get 9 plus 1 10 plus 3 lambda minus 4 minus 9 lambda minus 6 minus 16 minus 4 lambda equals to 0. On further simplifying it, I'll get 3 minus 9 minus 6 minus 6 minus 4 minus 10 lambda, and 10 minus 4 6, 6 minus 6 0 minus 16 equals to 0. So from here I got my lambda as lambda equals to 6 minus 16 by 10, which is lambda equals to minus 8 by 5. So I can just substitute value of lambda in this equation star, to get the equation of sphere. So my required equation of sphere is x square plus y square plus z square plus minus 8 3 is 24 by 5 minus 4x plus minus 8 minus 5 6 is 30 minus 38 by 5 y plus 2 minus 3 into 8 by 5 z minus 16 minus 4 into 8 by 5 equals to 0. So if I simplify it, I'll get x square plus y square plus z square minus 48 24 plus 20 minus 44 by 5x minus 38 by 5y plus minus 8 3 is 24 5 2 is 10 minus 14 by 5z minus 8 4 is 32 minus 80 minus 48 by 5 equals to 0. So this is my equation of sphere in first part. Further, it says that find the equation of sphere if the given circle is great circle of the sphere. So any circle is great circle of the sphere if it is the circle with largest diameter, and for any sphere, circle with largest diameter will be basically the circle passing through its center. So we'll basically use that result only. So we have general equation of sphere, using that we can calculate center. So my center of sphere will be 4 minus 3 lambda by 2 comma 6 minus lambda by 2 comma minus 3 lambda minus 2 by 2 will be basically my center of sphere. So the center of sphere must lie on given equation of plane. So if it lies on given equation of plane is 3x plus y plus 3z minus 4. 3x plus y plus 3z minus 4 equals to 0. So it will be 3 into 4 minus 3 lambda by 2 plus 6 minus lambda by 2 plus 3 into minus 3 lambda minus 2 by 2 equals to 4. So if I simplify it, 4 3s are 12 minus 9 lambda plus 6 minus lambda minus 9 lambda minus 6 equals to 8. So if I simplify it, 9 plus 10 minus 19 lambda, 12 plus 6 18 minus 6 12, so it will be 8 minus 12 minus 4, I guess. Or did I? 4 3s are 12 minus 9 lambda plus 6 minus lambda by 2 plus 3 into minus 3 3s are 9 minus 3 to the 6 equals to 8. Again 12 plus 6 18, 18 minus 6 is 12 again, so it will be 8 minus 12, which is minus 4. So my lambda is 4 by 19. So if I just substitute this value of lambda in the given equation of sphere, I'll get my required sphere. So my equation of sphere is x square plus y square plus z square plus 3 into 4 by 19 minus 4x plus 4 by 19 minus 6y plus 2 plus 3 into 4 by 19 plus minus 16, I guess, minus 16 minus 4 lambda, minus 16 minus 4 into 4 by 19 equals to 0. So this will be my required equation of sphere in that case. So let's move on to next question. So the next question says that find the equation of sphere for which this circle is the greatest circle. So this is basically similar to the second part of previous question. So equation of sphere will be x square plus y square plus z square plus 7y minus 2z plus 2 plus lambda into 2x plus 3y plus 4z minus 8 equals to 0. So if I simplify it, I'll get x square plus y square plus z square plus 2 lambda x plus 7 plus 3 lambda y plus minus 2 plus 4 lambda z plus 2 minus 8 lambda equals to 0. So I got my equation of sphere. Using it, I can calculate center of this sphere. So it will be minus lambda, comma, minus 7 minus 3 lambda by 2, comma, 2 minus 4 lambda by 2. This will be my center of sphere, and it is given that the circle formed by intersection of sphere and plane is a great circle. So this center of sphere must lie on equation of plane. So if it lies on equation of plane, it will be minus 2 lambda plus 3 into minus 7 minus 3 lambda by 2 plus 4 into 2 minus 4 lambda by 2 equals to 8. So if I simplify it, I'll get minus 4 lambda minus 21 minus 9 lambda plus 8 minus 16 lambda equals to 16. So if I simplify it, I'll get minus 4 minus 16 minus 20 minus 29 lambda, and on further simplifying it, it will be equals to 16 minus 8 plus 21, which is basically minus 29 lambda equals to 16 minus 8, 8 plus 21, which is 29. So I got my lambda is minus 1. So I can easily find out equation of a sphere. So my equation of required sphere is x square plus y square plus z square minus 2x plus 7 minus 3 4y minus 6z plus 2 plus 8 plus 10 equals to 0. So this is basically my required equation of sphere. So let's move on to next question. So next question is, they have given us a a variable plane passes through point this and meets the axis at point this, this and this. Find the locus of center of sphere passing through the point O, A, B and C, and where O is basically the origin of sphere. So let us assume a variable plane. So let my equation of plane be x by p plus y by q plus z by r equals to 1. So let this be my variable plane. So it is given that it passes through point A, B and C. So if it passes through A, B and C, so A by P plus B by Q plus C by R equals to 1 must be a relation. So let us name it as 2. Further, it says that the variable plane meets the axis at point A, B and C. So I can easily calculate coordinates of point A, B and C. So my coordinates of A will be P, 0, 0. B will be 0, Q, 0. And C will be 0, 0, R. So we are supposed to find the locus of center of sphere passing via OABC. And they have also given us O as origin. So my first aim should be to find the sphere passing via OABC. Then only I'll be able to locate its center. So any general equation of plane is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals to 0. Since the sphere passes via origin, my d term will be 0. So d equals to 0. Likewise, sphere passes via point A. So I'll get p square plus 2up equals to 0. And so also it passes via B. So using that, I'll get q square plus 2vq equals to 0. And using the coordinate C, I'll get r square plus 2wr equals to 0. So using these relations, I can easily calculate value of u, v and w. So my u is minus p upon 2 and my v is minus q upon 2 and my w is minus r upon 2. So if I substitute value of these u, v and w in this equation of sphere, I'll get my required sphere. But I guess there is no need to find that, no need to substitute these values, because center of any general equation of plane is minus u, minus v, minus w. So using that, my center will be p by 2, q by 2, r by 2. Now I am supposed to find the locus of any center of this sphere. So let x, y, z be locus of center of this sphere. Let me name it as star of star. Then x, y, z must be equals to p by 2, q by 2, r by 2. So using these values, I can easily find value of p, q and r. So my p will be 2x, q will be 2y and r will be 2z. Also, we have found a relation with p, q and r. So if I substitute my value of p, q and r in this relation too, I will basically get my locus. So that will be a upon 2x plus b upon 2y plus c upon 2z equals to 1. So my required locus will be a by 2 plus b by 2 plus a by x plus b by y plus c by z equals to 2. So this is my required locus of center of sphere. Let's move on to next question. So the next question is, find the equation of sphere of smallest possible radius which touches the straight line. So they have given us two lines, L1 x minus 3 upon 3 equals to y minus 8 upon minus 1 equals to z minus 3 upon 1. And my L2 will be x plus 3 upon minus 3 equals to y plus 7 upon 2 equals to z minus 6 upon 4. So if this is my sphere, so there are two lines which touch this sphere. So let this be my line 1 and this be my line 2. First let us see like what kind of lines are these lines, like whether they are intersecting lines or coplanar lines. Then only we'll be able to proceed. So first let us check their coplanarity, and using that, and for that we have a direct formula, so we'll use that is x2 minus x1, y2 minus y1, z2 minus z1, L1 M1 N1, L2 M2 N2, where these have usual meanings. So if this equals to 0, then these lines are coplanar, and if it is not equals to 0, then these are not coplanar. So let us check it. So it will be 3 minus minus 3 6, 8 minus minus 7, which is 15, 3 minus 6 is minus 3, minus 6 is minus 3, L1 is 3 minus 1 1, minus 3 2 4. Yeah, so if I simplify it, I'll get 6 into minus 4 minus 2 minus 15 into 4 3 is 12 plus 3 minus 3 into 6 minus 3, which is minus 36 minus 15 into 15 225 minus 225 minus 18, which will be, no matter what, it will be not equals to 0. So from here I can conclude that these are not basically intersecting lines. They are also not in, they also doesn't lie in same plane. So we are basically supposed to find the sphere which is at shortest distance. So since they are not intersecting and they doesn't lie in same plane, so these are basically skew lines. So if I can find any arbitrary point on this line L1 and arbitrary point on line L2, then the distance between them, if I can get the shortest distance between them, then that will be my diameter of this sphere, because these are skew lines and we are supposed to find the smallest possible radius. So radius will be smallest only when the diameter of my sphere is smallest. So let's just find out any arbitrary point on line L1 and L2. Let arbitrary point on line L1 be P, so it will be 3R1 plus 3 minus R1 plus 8 and R1 plus 3. Likewise, any arbitrary point on line L2 will be Q, that will be minus 3R2 minus 3, 2R2 minus 7, 4R2 plus 6. So if I can get direction cosines of PQ, so direction cosines of PQ will be 3R1 plus 3R2 plus 6 minus R1 minus 2R2 plus 15 R1 minus 4R2 minus 3. So any line with direction cosines proportional to PQ will be basically perpendicular to line L1 and L2. So using that result, we'll get 3 into 3R1 plus 3R2 plus 6 minus R1 minus 2R2 plus 15 plus R1 minus 4R2 minus 3 equals to 0. And if I simplify it, I will get 3 3 is 9 plus 1 plus 1 R1 plus 9 plus 2 minus 4 R2 plus 6 3 is 18 minus 15 minus 3 equals to 0, which is basically 11 R1 plus 7 R2 equals to 0. Similarly, this direction, any line with direction cosines proportional to PQ will be perpendicular to line L2 as well. So using that, I'll get minus 3 into 3R1 plus 3R2 plus 6 plus 2 into minus R1 minus 2R2 plus 15 plus 4 into r1 minus 4 r2 minus 3 equals to 0. So if I simplify it, I will get minus 9 minus 2 plus 4 r1 plus minus 9 minus 4 minus 16 r2 plus minus 18 plus 30 minus 12 equals to 0. So if I simplify it, I'll get minus 7 r1 minus 29 r2 equals to 0. So I can just solve star 1 and star 2 to get value of r1 and r2. So if I solve this, I'll get r1 equals to r2 equals to 0. So from here I got 2 points, basically the intersecting points P and Q. So this will also be the points of opposite ends of a diameter on a sphere. So my point P is 3, 8, 3 and my point Q is minus 3, minus 7, 6. And we have a direct formula to get a equation of sphere of which two diametrically opposite ends are given, and that is basically upon the idea that it makes angle 90 degree with this. So using that, we'll get equation of sphere as x minus 3 into x plus 3 plus y minus 8 into y plus 7 plus z minus 3 into z minus 6 equals to 0. So if we'll simplify this, we'll get the required equation of plane, or you can just leave it here for the time being. So this is basically the required equation of sphere. So let's move on to next question. So the next question is, a sphere of constant radius r passes via origin and cuts the axis at point A, B and C. Okay, sphere of constant radius r passes through origin and cuts axis at A, B and C. Find the locus of foot of perpendicular drawn from origin to the plane ABC. Okay, so let us assume, so if it is passing through origin, then if my point A is P, let's say 0, 0, and my point B is 0, Q, 0, and my point C is 0, 0, R. Also it passes via origin 0, 0, 0. So I can easily get equation of sphere. So my equation of sphere will be x square plus y square plus z square minus px minus qy minus rz equals to 0. So if this is my equation of sphere, then I can get coordinates of point A, B and C. So my coordinates of point, so okay, I have assumed this. So other way to do can be, you can just assume any general equation of sphere and then see where it cuts x-axis, y-axis, z-axis, and using that you can just find points A, B and C. I have just done it other way around. So any equation of plane via A, B and C will be x by P plus y by Q plus z by R equals to 1. So this will be any general equation of plane. So it says that we are supposed to find locus of foot of perpendicular drawn from origin to the plane ABC. So we can easily find the equation of perpendicular line to the plane ABC, which is passing through origin. So equation of that line will be x minus 0 upon 1 by P equals to y minus 0 upon 1 by Q equals to z minus 0 upon 1 by R. So if I equate it to any constant, let's say k, so I will get any arbitrary point on the line which is perpendicular to this plane star and passing via origin. So any arbitrary point will be x equals to k by p y equals to k by q, comma z equals to k by r. So if I further, okay, what I can do is I got my point x, y and z, and these are basically foot of perpendicular from a line via origin to the given plane. So if this is my xyz, so this foot of perpendicular must lie on star plane, so it will be k by p square plus k by q square plus k by r square equals to 1, which is equals to k equals to 1 by p square by 1 by q square plus 1 by z square. But here k is also unknown, so we are supposed to find k as well. So my k will be, okay, so let's do one thing. So I got x upon 1 by p equals to y upon 1 by q equals to z upon 1 by r equals to k. So I can write it as x square upon x by p equals to y square upon y by q equals to z square upon z by r. I can write it as like this, which is equals to k, and this is also equals to x square by x by p equals to y square by y by q equals to z square by z by r. I can just sum these up, x square plus y square plus z square upon x by p plus y by q plus z by r equals to k, and this term is equals to 1 using star. So from here I got my k as x square plus y square plus z square. So my relation so far is this one. Let us name it as star dash. Further in the question, they have given that the sphere is of radius r. So if r is my radius of sphere, then r square must be equals to center of sphere will be, radius from here will be minus p by 2, so it will be p square by 4 plus q square by 4 plus r square by 4. So from here I got p square plus q square plus r square equals to, let's name, just for time being, let's write radius as capital R, otherwise it will create some confusion, equals to 4 capital R square. So I got it as equals to 4 capital R square. Also from this result I can basically find value of p, q and r. Have I done that before? Yeah, from this here I can find value of my p, q and r. So my p will be k upon x, so p is basically k upon x square, so q is k upon y square, and r is k upon z square, which is equals to 4 capital R square. So on simplifying it, it will be k square 1 by x square plus 1 by y square plus 1 by z square equals to 4 capital R square. And I have already find out my k, so this will be equals to x square plus y square plus z square whole square, x is minus 2 plus y is minus 2 plus z is minus 2 equals to 4 capital R square. So this is basically the required equation of sphere. The required locus of foot of perpendicular. Also I have assumed that this is capital R for time being, because I have mistakenly taken small r as one of the coordinates which sphere is passing. So the next question is, find the equation of sphere passing via this and having center on this. So let us assume an arbitrary equation of sphere. So that will be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals to 0. Since it is passing via 1, 1, 2, so that will be 1 plus 1 plus 4 plus 2u plus 2v plus 4w plus d equals to 0. So if we simplify it, I'll get 6 plus 2u plus 2v plus 4w plus d equals to 0. Likewise, the sphere also passes via 1, minus 1, 2. So using that, we'll get 1 plus 1 plus 4 plus 2u minus 2v plus 4w plus d equals to 0. So on simplifying it, we'll get 6 plus 2u minus 2v plus 4w plus d equals to 0. Let us name these equations. This is 1, this is 2, and this is 3. So if we see 2 and 3, so using 2 and 3, we'll get our v as 0. So we got our v as 0. Also it says that the equation of sphere has center on this line. So if this is my general equation of sphere, then my center will be minus u, minus v, minus w. And it says that center C lies on x plus y minus z minus 1 equals to 0 equals to 2x plus y minus z minus 2. So this u minus v minus w lies on this line. So from here we'll get minus u minus v plus w minus 1 equals to 0 and minus 2u minus v plus w minus 2 equals to 0. So we got two more equations. Also, since I got my v as 0 already, so these equations will be reduced to minus u plus w minus 1 equals to 0 and minus 2u plus w minus 2 equals to 0. So I can just subtract these to get values of u and v. So if I just subtract these, so I will get u plus 1 equals to 0. So from here I'll get my u is equals to minus 1. If u is my minus 1, then w will also be equals to 0. Now I can just substitute value of u, v and w in any of the equation 2 or 3 to get value of d. So let's just substitute these values in equation 3. So we'll get 6 plus 2 into minus 1 minus these terms will be 0 plus d equals to 0. So I got my d as minus 4. So my required equation of plane is x square plus y square plus z square minus 2x. V and w are 0, so minus 4 equals to 0. So this is my required equation of sphere whose center lies on the given line and it is passing through these points. So let's move on to next question. So next question says that the plane this cuts the axis of coordinates in a, b and c. Find the equation of circle circumscribing triangle ABC. So my given equation of plane is x plus 2y plus 3z equals to 12. So it says that this plane cuts the coordinate axis at a, b and c. So we can easily find out coordinates of a, b and c. So my a coordinate will be 12, 0, 0. My b coordinate will be 0, 6, 0. And my c will be 0, 0, 4. So I got my a, b, c and coordinates. And we are supposed to find the equation of circle circumscribing triangle. So circumscribing triangle means if this is my equation of circle, then my triangle completely lies inside it. Also the circle passes via all three vertices of the triangle. So we are supposed to find equation of this circle, which is circumscribing triangle ABC. So it will be basically intersection of sphere passing via A, B, C and O. Let's say origin, it also passes via origin, and the plane. So we have equation of plane, we are only supposed to find the equation of sphere. So equation of sphere O, A, B, C will be, so since it is passing through origin as well, so my constant term will be 0 only. So let us assume any arbitrary sphere, that will be 2ux plus 2vy plus 2wz plus d equals to 0. Since it is passing via origin, so I got my d as 0. Likewise, it is passing via 12, 0, 0, so I'll get 144 plus 24u equals to 0. So from here I'll get my u as minus 144 by 24, which will be 2, 12, 6. So my u is minus 6 and my v will be 36 plus 12v equals to 0. So from here I'll get my v as minus 3 and my w will be 16 plus 8w equals to 0. So from here I'll get my w as minus 2. So my required equation of sphere is x square plus y square plus z square minus 12x minus 6y minus 4z equals to 0. But in question they have asked me to find the equation of circle which is circumscribing the triangle. So equation of circle will be basically intersection of this sphere and the given plane. So the given plane is x plus 2y plus 3z equals to 12. So these two equations combined is the equation of required circle. So let's move on to next question. So in next question they have asked us to find the equation of sphere in xyz plane passing through points. So they have given us 4 points and they have asked us to find the equation of sphere. So let us assume any general equation of sphere, that is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals to 0. Since it passes via origin, so I can directly write that my d will be equals to 0. Further it passes via 0, 1, minus 1, so it will be 1 plus 1 plus 2v minus 2w equals to 0. So it is 1 plus v minus w equals to 0. It also passes via minus 1, 2, 0, so 1 plus 4 minus 2u plus 4v equals to 0. So if I simplify it, I'll get 5 minus 2u plus 4v equals to 0. Further it passes via 1, 2, 3. So from there I'll get 1 plus 4 plus 9 plus 2u plus 4v plus 6w equals to 0. That is 9 plus 1, 10, 14 plus 2u plus 4v plus 6w equals to 0. So we have 3 equations in u, v and w. So using these we can easily calculate value of u, v and w. So if you see from here, I'll get value of w in form of v. So I'll get w is equals to 1 plus v. Likewise from second equation I can get u in form of w. So 2u equals to 5 plus 4v. So I can just substitute these value of w and u in this third equation to get value of v. That will be 14 plus 5 plus 4v plus 4v plus 6 plus 6v equals to 0. So if we calculate it, we'll get 6 plus 4, 10 plus 14v plus 6 plus 5, 11 plus 14, that will be 25. So from here I'll get my v as minus 25 by 14. Further my w is 1 plus v, which is basically minus 11 by 14, and my u will be, u is 2u is 5 minus 4 into 25 by 14. 14 5 is 70 minus 30 by 14. So u is basically minus 15 by 14. So I get value of u, v and w. So I can easily find the equation of sphere. So the equation of required sphere is x square plus y square plus z square minus 15 by 7x minus 25 by 7y minus 11 by 7z, and d is 0. So this is my required equation of sphere, which is passing via the 4 given points. So let's move on to next question. So the next question says that find the equation of tangent plane that can be drawn to this sphere through this straight line. Okay, so the given equation of sphere is x square plus y square plus z square minus 2x plus 6y plus 2z plus 8 equals to 0, and given equation of line is 3x minus 4y minus 8 equals to 0 equals to y minus 3z plus 2. So the tangent plane contains this line. So there are two ways to go ahead. First is to either just convert it into symmetrical form, the line into symmetrical form, and then assume any arbitrary point on it, and then that perpendicularity thing. But I think that will be too complicated. Not complicated, but that will be too long to solve. So what we can do is we can just assume the equation of plane which contains this line. So equation of any plane which contains this line will be of form 3x minus 4y minus 8 plus lambda into y minus 3z plus 2 equals to 0. So if I simplify it, I'll get 3x plus lambda minus 4y minus 3 lambda z minus 8 plus 2 lambda equals to 0. So this is my required equation of plane, which is basically tangent to the given sphere. So if this is tangent to the given sphere, then perpendicular distance from center of this given sphere must be equals to radius. So we'll be using that result only. So our given equation of sphere is x square plus y square plus z square minus 2x plus 6y plus 2z plus 8 equals to 0. So center of this sphere will be 2 comma minus 3 comma minus 1, and radius will be under root 4 plus 9 plus 1 minus the constant term, which is 8. So it is 10 under root 6 is the radius, I guess. Uh, 9 minus 8 1 4, yeah, under root 6 is basically the radius. So under root 6 must be equals to the distance between center and the tangent plane. So that would be 3 into 2 minus 3 into lambda minus 4 and minus 1 into minus 3 lambda minus 8 plus 2 lambda divided by under root 9 plus lambda minus 4 square plus 9 lambda square. So if I take squares both sides, so it will be 6 into 9 plus lambda minus 4 square plus 9 lambda square is equals to 3 to the 6 minus 3 lambda plus 4 3 is 12 plus 3 lambda minus 8 plus 2 lambda whole square. So if I simplify it, I'll get 6 into 9 plus 9 lambda square plus 16 minus 8 lambda, which is equals to minus 3, that is 2 lambda, 12 minus 8 4, and 4 plus 6 plus 10 whole square. So if I simplify it, I will get 3 into 10 lambda square minus 8 lambda plus 25, which is equals to lambda square plus it will be equals to 2 to the 4 into lambda plus 5 square, 2 times lambda square plus 25 plus 10 lambda. So if I simplify it, I'll get 30 lambda square minus 8 is 24 lambda plus 75 equals to 2 lambda square plus 20 lambda plus 50. And further simplifying it, I will get 30 minus 2, 28 lambda square minus 44 lambda plus 25 equals to 0, which is lambda equals to 44 plus minus, have I done something incorrect? Let me just check. Yeah, I guess we did a calculation mistake. Center of sphere will be 1 comma minus 3 comma minus 1. So my radius will be basically 9 plus 10, 11. It will be under root 3. So here it will be under root 3. Again here it will be 1. Let's just do it again from here, right? Because it will be time taking to just correct it here. So I get, if I just take square of both sides, I'll get 3 into 9 plus 9 lambda square plus lambda minus 4 whole square, which is basically equals to 3 minus 3 lambda plus 4 3s are 12 plus 3 lambda minus 8 plus 2 lambda whole square. So if I simplify it, I'll get 3, 9 plus 10 lambda square plus 4 goes a 16 plus 9 minus 8 lambda this must be equals to 2 lambda plus 4 plus 3 7 plus 7 square. And I can further simplify it. I'll get 30 lambda square minus 24 lambda plus 75 equals to 4 lambda square plus 49, 14 to 7 2s are 14, 28 lambda, which is equals to 26 lambda square minus 40, 44 minus 52 lambda plus 75 minus 49, which is basically 26 equals to 0. So I got it as lambda square minus 2 lambda plus 1 equals to 0. So it will be lambda minus 1 whole square equals to 0. So from here I got my lambda as 1. So if my lambda is 1, I can just substitute the value of lambda here to get the required equation of tangent plane. So my required tangent plane is 3x minus 3y minus 3z minus 6 equals to 0. So this is my required equation of tangent plane. So it further asks us to find a plane which passes through a fixed point and cut the axis here. So find the locus of center of sphere which passes through origin and OABC. I think we have done this question earlier. I guess this is a repeated question. So let's move. First question we did was this one only. So let's move on to next question. So the next question says that show that this plane touches the sphere. Also find the point of contact. Okay. So if we can show that the perpendicular distance between center of sphere and this plane is equals to radius of sphere, then we are good to go. So the center of sphere will be, so my equation of sphere is x square plus y square plus z square minus 2x minus 4y plus 2z minus 3 equals to 0. So my center will be 1 comma 2 comma minus 1, and my radius of sphere will be under root 1 plus 4 plus 1 plus 3, which will be 3 plus 4 9, which is basically 3. So 3 is my radius. So if I can show that the perpendicular distance between center and equation of plane is also 3, so that will prove that this plane touches the given sphere. So perpendicular distance from C to 2x minus 2y plus z plus 12 is equals to 2 into 1 minus 2 into 2 plus 1 plus 12 divided by 4 plus 4 plus 1, which is basically equals to 2 minus 4 plus 13 divided by 3, which is 13 plus 2. Here it will be minus 1. So it is 14 minus 5. Minus 4, 2. Here it is 11. 11 plus 2 minus 4, it is 9 by 3, which is basically equals to 3. So the perpendicular distance between center of sphere and the tangent plane is equals to radius, so it touches the sphere. Further, we are supposed to find the point of contact. So since I have center of sphere, also the given equation of plane, I can find the direction cosines of perpendicular of normal to the plane. So I can easily find equation of line via C and perpendicular to plane. So my equation of line will be x minus 1 upon 2 equals to y minus 2 upon minus 2 equals to z plus 1 upon 1. So if I got my equation of line and it is in symmetrical form, I can easily find any arbitrary point, let's say A on it. So any arbitrary point on it will be 2r plus 1 minus 2r plus 2 and r minus 1. And this point must lie on the equation of a plane because this is the point of contact. So it is 2 into 2r plus 1 minus 2 into minus 2r plus 2 plus r minus 1 plus 12 equals to 0. So if I simplify it, I'll get 4r plus 2 plus 4r minus 4 plus r minus 1 plus 12 equals to 0, which is basically 4 4 8 plus 1 9r, 2 minus 4 minus 2 minus 3 plus 12, which is basically 9. So from here I got my r as minus 1. So my point of contact is minus 2 plus 1 minus 1, it is 4 and minus 2. So this is basically my point of contact between the tangent plane and the given equation of sphere. So let's move on to next question. So the next question is, find the equation of sphere which passes through this circle and is cut by plane in a circle of radius 3. So given circle is x square plus y square equals to 4 comma z equals to 0 and plane is x plus 2y plus 2z equals to 0. So it is like, if this is my sphere and this is the required plane which cuts this sphere, then the circle formed by intersection of plane and sphere is of radius 3. So this is my 3 and here C is my center of sphere. So equation of any sphere which passes through the circle C will be, sphere will be of form x square plus y square plus z square plus lambda z minus 4 equals to 0 will be my equation of sphere. So from here I can easily find out center of this sphere, which will be basically 0 comma minus lambda by 2, and I can also find out radius of this sphere, which will be basically lambda square by 4 plus 4. So now I have this, let's say this is my point M, this is my point P. So now MP is given to me as 3. MP is given to me as 3. CP I calculated as it is equals to radius. Now if I can find CM, then I can easily apply Pythagoras theorem, because this will be perpendicular to the equation of plane. So CM will be basically the perpendicular distance from center of sphere to the plane, which is basically 0 plus 2 into 0 plus 2 into minus lambda by 2 divided by under root 1 plus 4 plus 4. So my CM is equals to mod lambda upon 3. So now I can easily apply Pythagoras theorem. Using that, I'll get CP square equals to CM square plus MP square. So if I just substitute these values, I'll get my CP is basically radius. So radius square is lambda by 4 plus 4, and CM square is lambda square by 9, and my MP is 3, so 3 square is 9. So if I simplify it, I'll get lambda square 1 by 4 minus 1 by 9 equals to 5, which is 9 minus 4. So from here I got my lambda square as 36. So my lambda is basically plus minus 3. So my required equation of sphere is, so I got basically two equation of sphere. So my required equation of sphere is x square plus y square plus z square plus minus 3 z minus 4 equals to 0. So this is my required equation of sphere. Let's move on to next question. So the next question asks us to find the equation of sphere on which the intersection of plane this with the sphere has dash as endpoints of its. Okay. Obtain the equation of sphere on which intersection of plane this with the sphere. So we are given one sphere which has these points as diametrically opposite endpoints. So if this is my given sphere and its intersection with the plane, and this is the plane with the sphere as endpoints, is a great circle. So the circle which it will be forming using this as its diameter, basically this. So I am supposed to find equation of this sphere, and I am given and diametrically opposite endpoints of this sphere. So let its endpoints be A and B. So AB is basically diameter of sphere S1, and I am supposed to find equation of sphere S2. And the sphere S2, the intersection of sphere S1 and plane and the given plane is basically the great circle of sphere S2. So my equation of, first let us find equation of sphere S1. So my sphere S1 will be x into x minus 3 plus y minus 1 into y plus 5 plus z into z minus 2 equals to 0. So if I simplify it, I'll get x square minus 3x plus y square minus 5 plus 4y plus 4y minus 5 plus z square minus 2z equals to 0. So if I simplify it, I'll get x square plus y square plus z square minus 3x plus 4y minus 2z minus 5 equals to 0. So this is my equation of sphere S1. And the equation of given plane is, plane is 5x minus 2y plus 4z plus 7 equals to 0. Now I have equation of sphere and the equation of plane, so I can easily find the equation of required sphere. So equation of required sphere will be required sphere S2 will be x square plus y square plus z square minus 3x plus 4y minus 2z minus 5 plus lambda into 5x minus 2y plus 4z plus 7 equals to 0. So if I simplify it, I'll get x square plus y square plus z square plus 5 lambda minus 3x plus 4 minus 2 lambda y plus 4 lambda minus 2z plus 7 lambda minus 5 equals to 0. And also it is given that this sphere, which is basically formed by intersection of sphere S1 in plane, is great circle to sphere S2. So if it is great circle to sphere S2, then center of sphere S2 must lie on the given plane. So let us find what will be center of sphere S2. So it will be 3 minus 5 lambda by 2 comma 2 lambda minus 4 by 2 comma 2 minus 4 lambda by 2, which is basically 3 minus 5 lambda by 2 comma lambda minus 2 comma 1 minus 2 lambda. So if it is lying on the given plane, so it will be 5 into 3 minus 5 lambda by 2 minus 2 into lambda minus 2 plus 4 into 1 minus 2 lambda plus 7 equals to 0. I can just simplify it to get value of lambda, which will be 5 3s are 15 by 2 minus 25 lambda by 2 minus 2 lambda plus 4 minus 8 lambda plus 7 equals to 0. So if I further simplify it, I'll get lambda into minus 25 by 2 plus minus 10 plus 15 by 2 plus 4 8 plus 7 15 equals to 0, which I can simplify further. 20 minus 45 by 2 plus 15 to the 30, it is again 45 by 2 equals to 0. So my lambda is 1. So since I got my lambda as 1, I can easily find out equation of the sphere, which is basically x square plus y square plus z square. I'm just substituting value of lambda here in star. So it will be 2x minus plus 2y plus 2z plus 2 equals to 0. So this is basically the required equation of sphere, which has great circle as intersection of plane and the sphere S1. So let's move on to next question. So the next question says that for what positive value of A this plane touches the sphere this. So if this plane touches this sphere, then the radius must be equal to perpendicular distance from center of the sphere to the plane. So we'll use that logic only. So my equation of sphere is x square plus y square plus z square minus 2x minus 4y plus 2z minus 3 equals to 0. So my center of sphere will be 1 comma 2 comma minus 1, and my radius of sphere will be underscore 1 plus 4 plus 1 minus plus 3. So it is 4 5 6 plus 3 9, which is basically 3. So 3 is my radius of sphere. So 3 must be equals to perpendicular distance of from center to this given plane. So using that, I'll get a into 1 minus 2 into 2 minus 1 plus 12 divided by a square plus 4 plus 1. So I can take square root of both sides. I'll get 9 into a square plus 5 must be equals to a minus 4 plus 5. 12 minus 5 is 7 square. So if I simplify it, I'll get 9a square plus 9 5s are 45 is equals to a square plus 49 minus 7 2s are 14a. I can further simplify it to get 8a square it will be plus 7 8a square minus 14a minus 4 equals to 0. I can write it as 4a square minus 7a minus 2 equals to 0. And since it is quadratic in 2, so we get my a as 7 plus minus under root 49 minus 4 into 4 into 2 upon 8. So a is 7 plus minus 49 plus 16 to the 32 upon 8, which is 7 plus minus 49 40 70 81 by 8, which is 7 plus minus 9 by 8. So my a is either minus 1 by 4 or 9 plus 7 16 by 8 or 2. But in the question they have asked us to find the positive value of a. So I can easily discard this value. So my a is equals to 2, for which the given plane is tangent to the given equation of sphere. So my equation of plane is 2x minus 2y plus z plus 12 equals to 0. Further, they have asked us to find the point of contact. So since I have center of sphere and also I know the direction cosine of normal to the plane, so I can easily find equation passing via center, equation via center and perpendicular to plane. So it will be x minus 1 upon 2 equals to y minus 2 upon minus 2 equals to z plus 1 upon 1. So any arbitrary point on this will be 2r plus 1 minus 2r plus 2 and r minus 1. And if it is basically the point of contact in between sphere and the tangent, then this point must lie on the tangent plane. So from there we'll get 2r plus 1 minus 2 into minus 2r plus 2 plus r minus 1 plus 12 equals to 0. So if we simplify it, we'll get 4 plus 4 plus 1 r plus 2 minus 4 minus 1 plus 12 equals to 0. So from here we'll get 9r plus 12 plus 2 14 minus 4 9 equals to 0. So from here I got my r as minus 1. So my point of contact, let us name it as a, will be minus 1 comma 4 comma minus 2. So this is basically my point of contact of tangent and sphere. So let's move on to next question. So the next question is, which point on sphere is at maximum distance from this point? So my given equation of sphere is x square plus y square plus z square equals to 1. And if this is my sphere and this is my point, let's say a, 2 comma 1 comma 3, this is a, 2 comma 1 comma 3. So in a, it has asked me that which point of sphere is at greatest distance from a. So this distance must be greatest. So what we can do is, we know equation of point a and we can basically find equation of straight line. So we can basically find equation of straight line passing via a and center 0 comma 0. So it will basically cut the sphere into 2 points, one which will be minimum, one at minimum distance and other at maximum distance. So equation of any line passing via a point a and 0 0 will be x minus 2 upon 2 equals to y minus 1 upon 1 equals to z minus 3 upon 3. And since this line cuts the, so we can basically get any arbitrary point on this line. So any arbitrary point here will be x equals, will be 2r plus 2 comma r plus 1 comma 3r plus 3. Since this is the point on, since this will be any point on the sphere where this line meets the sphere. So these points must satisfy equation of sphere. So from there we'll get 2r plus 2 whole square plus r plus 1 whole square plus 3r plus 3 whole square equals to 1. So if we simplify it, we'll get 4 plus 1 plus 9r square plus 4 plus 1 plus 9 plus 2 to the 4 to the 8 plus 2 9 to the 18 r equals to 1, which is basically equals to 9 plus 10 14 r square plus 14 minus 1 plus 13 plus 18 plus 2 20 plus 28 r equals to 0. So we can basically solve it for r because it is quadratic in r. So we'll get r is minus 28 plus minus under root b square, which is 28 square minus 4 into 14 into 13 divided by 2 into 14. So I got my r as minus 28 plus minus under root 28 square minus 4 into 14 into 13, which is basically 56 upon 2 into 14. So on further simplifying, I got my r as minus 28 plus 14 2 root 14, which is 2 into 14. So my value of r is minus 14 plus minus under root 14 upon 14, which is basically equals to minus 1 plus minus 1 by under root 14. So from here I got 2 points. So my 2 points on the sphere will be, let's name them as p and p dash. So they will be 2 plus 2 into r plus 1. So it is 2 into r plus 1 comma r plus 1 comma 3 into r plus 1. So from here I'll get my r plus 1 as plus minus 1 by under root 14. So my 2 points are p will be 2 by root 14 comma 1 by root 14 comma 3 by under root 14, and my p dash will be minus 2 by under root 14 minus 1 by under root 14 minus 3 by under root 14. So these are the 2 points where the line from A and center is intersecting the sphere. So now I just need to check at which point it intersect at minimum distance and where it intersect as maximum distance. So that I'll do using, if I calculate AP and AP dash, then I can get the distance. So my AP will be, so my A is 213, A is 213. So my AP will be 2 minus 2 by under root 14 square plus 1 minus 1 by under root 14 square plus 3 minus 3 by under root 14 square, and my AP dash is basically 2 plus 2 by under root 14 square plus 1 by under root 14 square plus 3 by under root 14 square. So if we see that only by observing, my AP dash is greater than AP. So my P dash is the farthest point. On sphere x square plus y square plus z square equals to 1 from point A, that is 2, 1, 3. You can also do this question using Lagrange multiplier method. So using that you can assume a function where assume any arbitrary point on the sphere and then just take the distance and try to maximize that distance subject to this condition. So let us move on to next question. So the next question says that find the coordinates of point on the sphere where the tangent plane at which are parallel to the, find the coordinates of the point on sphere the tangent at which is parallel. So tangent is basically parallel to this. So my equation of tangent is 2x minus y plus 2z equals to k. Yeah. Also the given sphere is x square plus y square plus z square minus 4x plus 2y equals to 4. So using this I can find out center of the sphere, which will be basically 2 comma minus 1 comma 0, and radius will be 4 plus minus 1 square 1 plus 4. So my radius is basically 3. So if this is my tangent, if 1 is my tangent to 2, then the perpendicular distance from center of sphere to this plane must be equals to radius of the sphere. So using that logic, 3 must be equals to 2 into 2 plus 1 minus k upon 2 square plus minus 1 square plus 2 square, which is again 4. So if I simplify it, I'll get as 9 into 5 minus k square, 9 into 5 minus k modulus. So that is basically 5 minus k equals to plus minus 9. So from here I got my k as 5 plus minus 9. So I got two planes. So the required tangent plane are at k equals to 14 and k equals to minus 4. So the tangent plane which are parallel to this are x 2x minus y plus 2z equals to 14 and 2x minus y plus 2z equals to minus 4. Oh, I guess we are not supposed to find the tangent plane. We are basically supposed to find the coordinates of the point where tangent is. So for that we can easily find the equation of line passing via center and perpendicular to the plane. So equation of line via center, that is 2 comma minus comma 0, and perpendicular to the plane of form 2x minus y plus 2z equals to 1 will be x minus 2 upon 2 equals to y plus 1 upon minus 1 equals to z minus 0 upon 2 equals to r. So any arbitrary point on this line will be 2r plus 2 comma minus r comma minus 1 and 2r. So this, if tangent is touching the sphere, then this point must lie on equation of plane. Find the coordinates of the point on sphere, the tangent planes at which we are supposed to find equation as well, because then only we'll be getting equation of the points of the coordinate. So since we have two planes, so we'll get two touching point as well. So one by one we'll just substitute this value in the calculated planes, that is this one and this one. So let's do for first one first. So it will be 2r plus 2 minus r minus 1 plus 2 into 2r equals to 14. So if we simplify it, we'll get 4 plus 1 plus 4r plus 4 plus 1 is equals to 14. So from here we get 9r plus 5 equals to 14. So from here we'll get r as 1. So our point of contact of plane 1, let us name it as 1, star 1. Star 1 and sphere will be A, where A is 2 to 4 comma minus 2 comma 2. Likewise we can calculate point of contact with star 2, plane star 2. So that will be 2 into 2r plus 2 minus r minus 1 plus 2 into 2r equals to minus 4. So if we simplify it, we'll get 9r plus 5 equals to minus 4. So from here my r is minus 1. So my point of contact with plane star 2 is, let's say, B. So it is 0 comma 0 comma -2. So this is my point of contact with plane 2. I guess this, yeah. There are more questions related to sphere as well that we'll do in part 2, otherwise length of video will be too long. So thank you for watching.